In the last lessons, we looked at how ionic bonds form when electrons are transferred from a metal to a nonmetal, and we end up with obviously charged particles that stick together. But that's not the only way an atom can reach a stable electron configuration. Another way atoms reach a stable configuration is by sharing valence electrons, and that's where the name covalent comes from. Co is together, and valence is referring to our valence electrons. So covalent bonding occurs when valence electrons are shared between two or more atoms. Now, these only form between nonmetals because nonmetals have 5, 6, or 7 valence electrons, which means they can share one or two of them. Shared electrons get to count for both or three of them, and that's going to make them feel like they have a full or 8 valent shell. Now, a molecule is what's formed when atoms are covalently bonded. And water is an example of a molecule, glucose is an example of a molecule, and H2 is an example of a molecule. So covalently bonded atoms are called molecules. Not all molecules are compounds, though. H2 is not a compound, it's just the element hydrogen because it only contains the same elements or atoms of the same element. Remember, a compound has to have two or more different elements bonded together. Now, there are 7 diatomic molecules that are not compounds. That's bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, and fluorine. That's easy to remember. That's Brinkelhoff. Now, these are important because these are always paired when not in compounds. Okay? So if you have a reaction that involves hydrogen, later you're going to see that hydrogen is always H2 if it's by itself. Same with the rest of these. So Brinkelhoff, the 7 diatomic molecules, if they're alone, they're not alone. If they're not in a compound, they are as diatomic molecules. And so when you name those, you just call them bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, and fluorine because they are elements. Now, molecules get named a little bit different. Molecules have some naming rules. And so if we have two different atoms, and again, that's all we're going to look at is binary compounds, then you name the first element with the appropriate prefix. I'll look at those in a minute. However, we don't use mono on the first one. If there's only one of the first element, we don't use mono. And then you use a prefix and the second element, and then you change the ending to IDE. So that's like we did with ions, we do it with molecules as well. We change the ending of the second element to IDE. Now, our prefixes are mono, di, tri, tetra, penta, hexa. If we needed 7, 8, 9, and 10, we would go hepta, octa, nona, and deca. We probably won't get into any molecules with those, but if you need them, those are the prefixes. Now, if we have electrons being shared, we're going to look at how this happens in a minute. We can actually share more than one electron from each atom. So if one pair of electrons is shared between two atoms, a single bond is formed. So like fluorine as it forms a bond, or water when it forms a bond. Let's look at what actually happens when these bonds form. And it's easier to do this with electron dot diagram. So fluorine, if you remember, is in group 7. It's a halogen. It has 7 valence electrons. It has a spot for one more. It's one short of having 8. So if I have two fluorine atoms, each one of them has 7 valence electrons. And what we can see is these two right here can actually bond and form a shared spot. And so these two electrons actually get to count for both fluorine atoms. They both think they have those two. They're both attracted to those electrons. And we represent this with a single line. So we have our fluorine with its 6 valence electrons and then its pair of shared electrons, and then the other fluorine with its 6 valence electrons. Now that line counts as the 2 electrons, and so if we count it up, 2, 4, 6, 8 for the left fluorine, and 2, 4, 6, 8 for the right fluorine. They both obey the octet rule. This is a single bond because it's one pair of shared electrons between two atoms. Water does the same thing. If we start with oxygen, we have it's a group 6 element, so it's got 6 valence electrons. We can see it's got 2 unpaired electrons, so 2 places it can form a bond. Hydrogen is special. Remember, it only needs 2. It's trying to look like helium. It only has 2 electrons in the first energy level. So these two can share, and then another hydrogen can share right here. This is still single bonds because even though oxygen is making 2 bonds, it's with separate atoms. So what we have is oxygen with its 2 unshared pairs, and then hydrogen with its shared pair, or other hydrogen with its shared pair. This guy and this guy, those are called our structural formulas. They show us the bonds that happen or form on these atoms. This is two single bonds, this is one single bond, but it's a single bond because only one pair of electrons is shared. That means it's probably possible to have more than one pair of shared electrons. And we can see that common example is oxygen. Remember, we've got two open spots or two unpaired electrons that will form bonds. And so if we have another oxygen atom hanging around, we'll have another two open spots. And so these two can share and these two can share. And that gets us oxygen with a double bond. That two lines, each line represents two electrons. So if you count it up, 2, 4, 6, 8 for the right, 2, 4, 6, 8 for the left. They both obey the octet rule, and they both form two bonds with each other. This is a double bond because we have two pairs of shared electrons. Nitrogen will form a triple bond. Nitrogen has 5 valence electrons. So if there's another nitrogen atom hanging out here, it's also going to have 5 valence electrons, and that leaves us 1, 2, 3 open spots on each one. And so these two can share, these two can share, and these two can share. And what we end up with is two nitrogen atoms with 3 pairs of shared electrons between them. They each will obey the octet rule. This is a triple bond. So we get a double bond with 2 pairs of shared electrons, and we get a triple bond with 3 pairs of shared electrons.